This video is about the normal distribution. So previously we looked at the binomial distribution. Here we're going to look at the normal distribution. So the curve is bell-shaped. It is symmetrical about the mean, which would be here, and the mean, mode, and the median are all the same. If a random variable x has a normal distribution with mean mu and standard deviation sigma, this is written like this, where mu is the mean average and sigma squared is the variance. Remember that the variance is just the standard deviation squared. The mu and the sigma are called the parameters of the distribution, just like when we had the binomial distribution, we used n and p as our parameters. The mean is the central point of the distribution, and the standard deviation describes the spread of the distribution. The higher the standard deviation, the wider the normal curve will be. The area under a normal distribution curve is always equal to 1. And the standard normal distribution is the distribution where the mean is 0 and the standard deviation is 1. The random variable is called z when you're working with the standard normal distribution. It uses z values to describe the number of standard deviations any value is away from the mean. We write the standard normal distribution with a z instead of an x, and then with the parameters 0 and 1, because those are fixed for the standard normal distribution. You can use your GDC to calculate the areas under curves of the standard normal distribution for values in between a and b. Hence, you can find the probability that z is between a and b. So let's look at some practice using our graphing calculator. So for these, we're going to use our standard normal distribution, and we're going to find the following probabilities below using our graphing calculator. So the first one, we're looking at the probability that z is between -2 and 1. And so in your graphing calculator, I'll put the steps here. So you're going to press second and then var. So that allows you to select the distribution option on your calculator. Then you're going to select 2, which gets you normal CDF. Okay, the arguments for this function are the minimum, the maximum, and then you're going to use mu and sigma, and then you would press enter. On a newer graphing calculator, it probably just asks you to enter them and tells you what it is. If you have an older graphing calculator, you'll need to enter them as arguments, just in this order. So here, what should display on your screen is normal CDF, and then in the older calculator, you would have -2, 1, 0, and 1, and then you would put your answer beside here, and you should get about 0.819. Okay, so again, this is the calculator notation. You don't want to include that in your solution, but plugging this into your calculator, that is how you get to that 0.819 answer. Okay. Let's try another one. So now we've got the probability that z is less than 1. So this causes a little bit of a problem because we don't have 2 options or 2 endpoints of our interval. So what we're going to assume is that if z is less than 1, our other endpoint, you can sort of imagine it over here, is just going to be a really, really, really big negative number. Okay. So we've got on our calculator, so what you'd enter on your GDC is normal CDF. Make sure you're using CDF. We're not going to use PDF. -9 times 10 to the 99 1, 0, and 1. That's what you should enter in on your calculator, and it should give you the answer of approximately 0.841. Okay. Let's look at another example here. Now we've got a difference again where you've got z is greater than minus 1.5. So now we don't have a right-hand value of our interval. So we're going to do the same thing. So our right-hand, let's use right-hand limit, is just going to be a really big positive number. So again, we're going to use our graphing calculator. So you should enter normal, CDF, your left interval, your right interval, and then the parameters of your normal distribution, which in this case are 0 and 1. And so then I'm just going to move this down here. So our right-hand limit is approximately 0.933. So the probability that our random variable z is greater than minus 1.5. Okay. Our next example, now we're looking at the probability that our random variable z is less than 0. Okay. This one's kind of a tricky question, or not tricky, but a little bit of a subtlety. This is actually equal to 0.5. The reason for that is that the graph, the mean of our distribution, is 0, and our graph is symmetric about the mean. Okay. So kind of a neat connection there. We don't even have to use our calculator for that one. The last one that we're going to look at here is the probability that the absolute value of z is greater than 0.8. Now we sort of have to think about what that really means. So we can either have, if z, the absolute value of z is greater than 0.8, that means that we can have z is either less than negative 0.8, or we can have z is greater than 0.8. So that means we can keep going. The probability that we're looking for is 1 minus, let's see if I can write this out, the probability that z is between minus 0.8 and 0.8. That's really what we're looking for. So let's fill this in. Probability that the absolute value of z is greater than 0.8 is equal to 1 minus the probability that z is in between those values. That I can use my graphing calculator to figure out, this part right here. So on my graphing calculator, I would get to the normal CDF function. Again, making sure you're using CDF. We're not going to use PDF. And then our entries would be our left interval point, the endpoint on the right-hand side, and then our mean and our standard deviation. Okay, so this I can evaluate all in one step on my calculator, and it comes out to approximately 0.424. So another neat way to use your calculator, we're looking at finding the area underneath a normal distribution curve to determine the probability that a variable is between 2 points. Probability that a random variable is between 2 values. Hopefully this was informative for you and a good resource.